So why is this interesting to me? Basically, I have an electrical problem with my car. And so I want to know how to kind of work around it. And by doing that, I need to start learning a bit more about electronics. And electronics are pretty interesting in general anyways. Because, like, me having the ability to program software is nice, but having the power to, like, do stuff with hardware is even more interesting. Like, the power just expands. Gives me more power to do stuff. On top of that, it helps you actually, gives you good debugging skills for figuring out, like, what's the problem with the electronics that you use day to day. Also, the repairability of anything that you own is just a lot better if you actually understand. And you can read, for example, like electrical diagrams and stuff. What's the issue with my car? So here's the thing. My car, let me show you. If you really want to know. Let me see if I have a page that shows the flow there correctly. Okay, maybe this will do well. Okay, so the suspension in my car looks like this. So there's an ECU. There's an ECU here, which is like what's the abbreviation? Electronic control unit. Electronic control unit. And a suspension. So these are like attached to the wheels, and if I drive into a bump, so like my wheel goes up, then this piston will push into the liquid and will push the liquid into the sphere, and the sphere is nitrogen gas, which is which you can compress. Liquids you cannot compress. So at some point this piston will go up and it will not go further, because at some point the gas is compressed enough and the liquid is not compressible, making it like level out basically. So at some point the wheel will go back and the gas will, we'll make sure that it's a smooth transition into lifting one wheel up. It's a very nifty system. Glad I didn't decide to study electro engineering. Looks hard. This is not even electrical engineering. This is literally just mechanical. It's mechanical engineering. With some electrical parts. So if you have a wheel, let me just like make a screenshot of this and just put it in Paint. It might be easier. So if I have a wheel like here, probably a little bit round here. So if I have a wheel here and I have a wheel on the other side, same way. Oh. Shit. Paint is such a shit program. And I have a wheel here. So if one of these goes up, right? Like this. Then this piston will push into the liquid here, pushing this into the sphere, and it will like bulge out. There's like a rubber membrane here that's like pushing into the nitrogen gas, which will dampen this thing going up, and it will at some point not go further up, right? Like you don't want your wheel to fucking break off, you know? So like this will go up and it will reach a certain point, and then when it goes down, the piston goes out and the liquid like flows out and the gas, is free again. It's great. It's a great like oh, you guys can't actually see it. Fuck. Shit. Oh no. I just realized that I just explained everything, but like it doesn't. It's like cropped off. Oh shit. Okay, let me just reset. My bad. God damn it! I kept explaining something, but you guys couldn't even see it. Oh, this is the screen. Yeah. Okay. Wait, maybe the other scene is better. All right. Right, so if the wheel goes up, whoop. This piston goes up, whoop. Pushing into the liquid here. Liquids are not compressible, so liquid will just like push into the gas, which is compressible, meaning that you have a smooth transition into going up. To make the engineers looked at this and they were like, this is nice. This is very nice. And this same like compression is also used to brake, to do power steering and all that jazz. And so if you move the steering wheel, the pressure from this liquid will help you steer, and it will, it will also trigger the brakes. Like, you know how brakes work in a car? It's using brake liquid, right? It's like liquid that is helps that with added pressure from your pedal, like your brake pedal. If you push that in, you push basically the liquid further into the valves, pushing the two things together. So let's say we have your brake pedal here. That's like a simplified explanation, right? There's like a little bit more nuance to it, but like you have like your brake fluid right here, which is like this. It's like this full, you know? And then there's things going, oops, from here to your actual wheels. So this is the brake pedal. So let's make that a little bit more clear, like this. Maybe that's not even that like your foot goes on here, okay? Your foot goes on here. And then there's your wheels, which look like this, which also have these lines, which is like makes it even more confusing. But this is like your wheel. And so then there is like a brake, which is just you get there's two types of brakes, but let's just take the simple ones, right? Like let's say you just have blocks. You just have a block here that pushes onto another block. So this wheel has a block here, and then these blocks are not against each other. So this one is off normally. As you drive, normally this wheel is free to move whatever way they want. That's all good to go, you know? This is all good to go. This wheel is like free to move. The brakes are not pressed. But this thing is filled with this liquid. So this thing is all the way filled with this liquid. And then as you press the brake panel, you pressurize this cable with liquid, or like this pipe. So as you push the brake pedal further, so like let's say we push the brake pedal further. How do I do that? This way? All right, let's just do it manually. So as you hit the brake panel, so it goes like a little sideways, you know? God, new paint, boys. God, this is so annoying. Okay. So you pushed in the brake pedal a little bit, right? You put your foot on the brake. The pressure rises in this thing, which pushes this block onto the wheel. So like it like, with the pressure of the liquid, which is not compressible, you're basically force pushing this thing onto here, which causes friction, and friction physics will slow down the car, slow down this wheel. And if you do this at multiple places, you will have the friction stops the wheels. So that's just basically like, liquids are not compressible, which means that if you put pressure on them, they will just flow to whatever spot they have, and if they don't, then you're just gonna force something out, right? You're gonna force something to move because of the pressure that is on here. While gas is compressible to a certain extent. But liquids are not. So if we take that philosophy, and this is not just water here, because water, you know, causes rust to happen and corrosion, and so we don't want that. So there's like a special liquid that goes in here. So like if this thing goes up, it pushes into this gas, it compresses the gas, and you have a smooth suspension. Now that's all cool, but the engineers thought, you know what? Let's make this sphere even more comfortable. So what we're gonna do is we're gonna connect both of these spheres, and liquid from like the reservoir, which is this thing here, which was similar to this thing, it's just filled with liquid, is free to move from like one wheel to another to help with like rolling and like dampening and whatever. So if both wheels are at the same time, like there's more pressure and stuff like that. And then at some point, the engineers thought, you know what, let's just add another one. Let's just add another sphere for extra, you know, dampening. So there is electronics in place to decide whether this sphere is used or not, depending on the safety of the car. So if I'm driving in a corner and my suspension is way too like fluid or like way too like smooth, this could mean that I'm like losing control and the car rolls over. Right? Like if I'm making these things like ultra smooth and there's so many spheres to dampen, like with this nitrogen gas, you will at some point lose the suspension firmness and you will just roll the car because like you're leaning into, you want to make a turn to the left, which causes the car to dive to the right. And so in some situations, they realize like we don't want to always have this on because that's dangerous. Like if you're driving fast and you're moving fast into a corner, then you might just roll over, and we don't want that. So they created an ECU for this exact purpose. So they programmed a bunch of sensors on the car, like steering wheel rotation degrees, how fast are you going, which is a speedometer that is on your car. And there's a shit ton of more like sensors that are on the car that this thing takes into account to decide whether this thing is going to be open or not. Okay, that's cool. But on these comfort spheres is what they call them. There is also a diode on there to make sure that if it breaks down, that the ECU doesn't break down. But this diode is like very cheap, and so it burns out very quickly. And so there is cases where this ECU is actually burned and you need to like replace some parts into it. So what we did is we soldered some diodes inside the ECU so that there's some extra protection there to make sure that this ECU doesn't burn. But basically what this electronics are basically just doing is deciding whether to push this piston up, which blocks this sphere, or to let it slide down and it opens up and it can freely move. So right now it's open because you can see the liquid flowing from one side and flow to another. So program, play and chill, how's it going? And so now it's open. But if this thing is like down, if I if I can make paint actually work. Like this, you can see that it blocks the path from flowing both in between each other and from flowing into this sphere. So what the car manufacturers also decided is like, what if something goes wrong? We don't want the car to be in comfort mode because that's unsafe. Because if you're driving fast, it might roll over. So what they decided was the default state without any electronics is this thing closed. So by default, this thing is closed and you will not use this sphere at all. It will do that when any sensors are broken, it cannot decide anything, one of these electrical parts is broken or whatever. So there's a lot of factors that can cause this ECU to be like, yep, nope, I'm going into like firm suspension mode. I don't trust this shit, so we're just going into firm suspension, which is just like your regular car. So right now my car is not using this sphere at all, which is pretty sad. And we want that thing to be working because that's the whole special thing about this car. So there's electronics involved here, and there is some websites that have told me that you can also, instead of like connecting these spheres to the ECU, you could also just connect some LEDs to the input of this, so you can actually see when the car decides to shut this sphere off or not. I'm not good enough with electrical engineering to be able to do that. But I think through learning, I will eventually be able to figure this out and measure. There's one thing though, I cannot just check whether there is electrical pulses going to this electrical machine that handles this piston, because of the way power is sent to this electronics unit. So there is 12 volts, which is quite a lot, going to the first pulse on this machine, which is enough to trigger this piston to open up. And after that, it switches to like 3 volts to make sure that these electronical parts don't burn out. Well, that doesn't always happen, so some of these parts will burn out eventually, which is something you need to check. But you cannot just put a multimeter in between, because they're sending small pulses of electricity through it every time, which means that your multimeter is just going to show different values because it's taking the average. So it might send 12 volt first and then nothing, and then 3 volts and then nothing, and then your multimeter is just gonna flip the fuck out because it doesn't understand. So like how you would really need to test this is through an oscilloscope, I think, is like when you can see like electrical waves and stuff. I don't have that. So yeah. So this is not really electronical engineering. This is just an explanation of the suspension system on my car, which is mostly mechanical work, but there's some parts that are electronics. And these electronical parts are the ones that are hard to debug unless you have like some way of connecting to the ECU, which shows like whether you have like a fault or not. The problem is these like these cables are not manufactured for my car anymore. So I cannot just read out and see like, hey, I am now running in like firm suspension mode, or I'm running in smooth suspension mode, because I don't have the cable for this. And even like the dealers of these Citroen cars, even though they don't always have this anymore laying around, because these cars are not made anymore. This car is 26 years old. So that's a problem. And so I'm trying to search for a way to read this out anyways. And then there's some Chinese knockoffs that are making cables that are 50-50 chance whether they work or not. So yeah, I'm trying to figure it out. Anyways, if you guys are interested in that too, maybe I'll just do a car engineering stream. Who knows? I don't know. Maybe a YouTube video. I don't know. It's interesting. It's very interesting to me, though. It's very interesting to me. You think I have a scope somewhere? Oh, nice. What's up, how's it going? Signal in waveform. Yeah, exactly. And I think that's what you need because these pulses are so short. And the reason that they're using pulses is because this system needs to be able to switch super fast whether to turn it on or off, because you don't want to be in a corner and the system takes like a second to decide whether it goes firm, because within that second your car could have flipped over. There is people that just remove this ECU altogether and they just have this firm suspension always off. So like they just basically force this piston to always be open. But I also don't want that, because that just takes away the interesting part of this car, you know? Like it's the whole system that just checks whether or not it should be firm or not. That is like the interesting part. That would be like a waste of engineering work. You have a floaty car, yeah, which is nice, but like if you take a very hard, like fast corner, you might just roll over. I can show you what it looks for. So you can see here, if you're driving 34 to 39 kilometers an hour and your steering wheel is at 174 degrees, that's when it would turn to firm mode. Make it a bit bigger. And then like I also have a sport button which I can press, and then it's a bit earlier. So like when I push the sport button, it's like 119 degrees, it goes to firm. And so like you can see, like based on vehicle speed sensors, versus like the steering wheel rotation, the gas pedal sensor and stuff like that, it decides whether or not to put it into firm suspension mode or not, which is super ingenious if you think about it. Like why would we have like a normal suspension system if you could have a smart suspension system? And this is a car from 1993. Like my car is from 1994, but this is like the first car was made with this suspension with like 1993, which is insane. So it's like nuts to me that they came up with this idea that if you're we could decide whether to use firm or smooth floaty, like almost floating like magic carpet ride like suspension, just based on looking at sensors alone. The downside of this system though is very hard to debug if you don't have, you know, the readouts from the ECU. And as you can see, just like what I explained before, is like in soft mode this piston is up, as you can see, so it allows it to float freely. But in hard mode, this piston is blocked, which means that this sphere is not used. So that's exactly what I showed. So this is what I'm super interested in, and it's super interesting stuff. And that's the problem that I'm having right now. Just so you guys know. So we need to get you a scope. I don't know if that's gonna help. So next week, I'm going to my parents, and I'm also on this Citron forum. Sub Lava, sub Mitrin. And I'll be going to one of the members that have this old like ECU cable. So we're gonna see if that cable is working with my car, because this is a first generation like car like this. So there's like two versions of this car. There's the one made in 1993 until 1998, and then there's one from 1998 until 2002 or something. So I have version 1, and not every single, you know, plug works with this car. So we need to see. But I don't know if you guys think this is interesting, but to me that was very interesting. And when I looked at that like technique, I was like intrigued, you know? I was intrigued by how somebody could come up with that idea. You know, like how somebody thought of the idea of like, you know what, why not just make the suspension using liquids? rather than, you know, like your normal, whatever. Don't touch the springs. So there's only one spring in this car. There's no springs in my car. Because it doesn't need it. It's all liquid. It's all just liquids, which makes it super simple too. So I don't understand why car manufacturers stopped using this technique. Because springs need to be replaced. And then you also have that other thing that is like inside the springs that just the shock breaker. I don't know what it is in English. Shock breakers? Probably shock breakers. Makes sense. You need to replace all of these parts. And then the brakes. Shock absorbers? Yeah, shock absorbers. Makes more sense, yeah. All of these parts you need to replace. While with this car, it's all in the sphere. You have these spheres with nitrogen gas and liquid. And then your brake with those. Your steering pump. You don't need a steering, like, power steering pump because it's the same system. Your suspension works with the same system. And then they have some safety measures. Like it blocks off some of the system so that your brakes will always work even when, you know, something goes wrong. And then you also have your handbrake, obviously, which is not on this system. But like if I need to replace something, all I need to replace is those spheres and then the pipes, you know? And that's it. It's pretty interesting, pretty nifty. So in theory, it's pretty cheap, but maybe that's the reason that they don't want to go for it. It's because people just don't understand. Yeah, my car is exclusively hydraulics, which is super interesting. And there's some safety measures for it too. You know, you don't want when your like pipes break, you don't want like, or like when your fuel leaks, you don't want your car to be not usable anymore. All right, so yo, Leah, great, Chuck, thank you so much for the follow. Appreciate that. So let's get this party started. I also need to somewhere in between this stream, I need to cook. But what we're going to work on today is we are going to be working with the Arduino, which is obviously this stream's title. We have the Arduino starter kit, which we've used before, but I've never continued. Which contains like a book, and it tells you what all of the things that it contains. Like breadboard, you know, the Arduino itself, diodes, LEDs, cables, resistors, LCD displays, optocoupler, whatever that is, temperature sensor, tilt sensors, transistors. And so it will be very interesting if I start to learn electrical engineering, that I could then go to my car, because this is my goal, right? This is my goal. My car switches between normal suspension and then firm suspension all the time, like depending on the sensors. If I could hook into that electrical system and show based on LEDs whether the system is in firm or normal suspension, that would be fucking awesome. Because then I could actually get an understanding of like how it works. Someone who actually studies mechanical engineering could probably properly explain why full hydraulics are used less. True, probably. I honestly think it's because so Citroen was bought by PSA, or it became like it fused with PSA, which is Peugeot, Citroen, DS, and Opel, which is not even a French car, but like PSA is like the French car like collective or something. And so what I think is like they just combined all the systems and they were like, you know what, fuck this shit. It's too expensive to do it like this. Is that there's nothing more dangerous than somebody studying physics. Someone studying physics fixing a car. I mean, you know, I'm not gonna take any risks. You know, like my car needs to be safe first and foremost. I'm not gonna play around with my car if I don't know what I'm doing. Okay, so what we're gonna do is we're gonna kind of recap what we've learned last time. Because it's been a while. So we know what everything is. We've done a bunch of projects. Yeah, my Mac is turned on. I think. Or it was turned on. Shit. Copper is waste transferring signals / data while having galvanic separation. I don't know what that means. Electricity is a type of energy, much like heat, gravity, or light. Electrical energy flows through conductors like wire. Yeah, so conductive material, I didn't know what that is, but that's just everything that just kind of like transfers energy, right? Like transfers electrical energy. So like rubber is not a conductive material, right? While copper, for example, is. Am I correct with that statement? I wish I could make this closer so you guys could actually read with me. We need like some magnifying glass. But then it would also be flipped. Wait, can I zoom in? One reason I think of is that hydraulics liquids cannot be compressed very much. Think construction equipment. Pneumatics gas can be compressed to a much greater extent. Think air compressors. Yeah, but this is like a combination of both. Welcome, dog, by the way. Thanks for joining in. Okay, so components you might use to do this, like speakers or light bulbs, are electrical transductors. So transductors change other types of energy into electrical energy, and vice versa. Things that convert other forms of energy into electrical engineering are often called sensors, and things that convert electrical energy into other forms of energy are sometimes called actuators. Okay, that makes sense. A sensor might read something and then translate that to electrical energy, right? Like if I'm like trying to measure, I don't know how sensors work, but they're transforming something like, let's say you want to measure how much liquid is in it checks that and transforms it into electrical energy. No? Is that am I reading that wrong? You will be building circuits to move electricity through different components. Circuits are closed loops of wire with a power source like a battery and something to do something useful with the energy called a load. Yeah, makes sense. Cool. This makes a lot of sense. We've already been over this. In a circuit, electricity flows from a point of higher potential energy, the plus, to a point of lower potential energy, ground. Oh, no. Lower energy. Ground, often represented with a minus, or GND, is generally the point of least potential energy in a circuit. That's actually important detail. That's an important detail because you can build circuits that are not going to ground. They might go to ground eventually, but like in your circuit, it does not go to ground. It just goes to the least potential energy in the circuit. But in this case, what we're building with this breadboard is literally just, we're moving it to ground. Important detail though, I think. Because like, okay, no, I'll just continue. I have a funny story about what I googled. Let me see, where was I? In the circuits you're building, electricity only flows in one direction. This type of circuit is called direct current, or DC. In alternating current, AC circuits, electricity changes its position or its direction 50 or 60 times a second, depending on where you live. This is the type of electricity that comes from your wall socket. Correct. It's important for a transistor and how it works. Yeah. Exactly. And this is an important thing as well. The difference between DC and AC. So AC is like what comes out of your wall changes direction, like change the flow of energy a lot, which means like that's where this diode comes in, right? Because like the diode basically only flows in one direction. Like the energy, it forces the energy to only flow in one direction because there is infinite resistance on one side, while the flow of energy for the other side is like near barely any resistance, like barely. It can almost flow freely, and I say almost because it's not entirely. So this is what I searched. I'm just verifying whether that's correct. So for AC, for alternating current circuits, I've noted how you would like work with that, but yeah. Forgot how transistors work. It's all in here. It's all in here. We can take a look at it in a bit. There are a few terms you should be familiar with when working with electronics. Current, measured in amps, with the A symbol, is the amount of electrical charge flowing past a specific point in your circuit. So this is where I really would like to use this today. So I bought a multimeter. I have never used this in my life, but I would really like to see if I can make use of this tool within the circuit that we're building today, because it's important. And since we're working with like low voltage, this should be fine to work with today. Or low current rather, sorry. Voltage measured in volts with the V symbol is the difference in energy between one point in a circuit and another. So if you're saying we're connecting a 12-volt battery to our circuit, that would mean, because ground is ground 0? Because then it's like the difference is 12 volts to 0 is 12 volts, right? So like our system is running 12 volts all around, right? But then if you have a different circuit where you have your minus point, or your like, what is it called? Your point of lower potential energy, or the minus, could be something else. And then the difference between that could be something else, right? So like the voltage of a 12-volt battery is only 12 volts because it's measured against ground. Is that correct? Am I correct there, or is it still a 12-volt battery always? Because they called it 12-volt battery. Like if, I don't know. Anyways. Okay, then there's resistance measured in ohms, which is basically how much a component resists the flow of energy. Yeah. So I remember struggling with this in the beginning, but I know how it works now. But I can show you guys the thing. So the current is the amount of actual rocks rolling down the hill. Resistance is trees that are slowing it down. And voltage is the amount of like potential it has. Kind of. So like if we're reading, one way to imagine it is think about rock slide going down a cliff. The higher the cliff, the more energy the rocks will have. So the higher potential energy there is, right? So there's like, the difference in volt here is like, or your circuit is considered 0 volt. Yeah, exactly. So the bottom of the hill is 0 volts. The top of the hill is whatever this voltage is. The current is how much actual energy flows through, and then the resistance is basically cutting the amount of energy that flows through. So it's like slowing it down, or like it cuts on the potential energy because it slows it down. So like by the end it might be different. Basically used to protect parts, you know? If like 5 volts are flowing from one side to ground, and you put like an LED in between that cannot handle like, I don't know how to calculate that, but like the amount of current that flows from 5 volts to 0 volts, then you need to put resistance in place to make sure that you don't break your components. It, yeah, reduces the current. Potential current that flows through. Hope that I got that. It's probably some nitpicky situations there. But I remember last time that I was struggling with this hardcore. I remember last time some people said you could think of this as a highway. So let me open Paint again. I remember somebody using that analogy. Because with this rocks on the hill, I thought it was a bit awkward. So if you have a highway, a 2-lane highway, and it goes into one, and there's cars here, and they're flowing like, it's like always full, basically. This highway, these circles are cars, by the way. No matter how like high traffic this is, because fucking energy is super fast, they will still need to merge, so it will slow down regardless, right? So because of a resistor, we're cutting off the potential amount of energy coming from 2 lanes. So this is like, this stuff is like 5 volts, right? And then the ground is 0 volts. That's like minus, is the plus. So we're flowing 5 volts to 0 volts, but because we're putting a resistor in place, like I think it's this sign, right? We're cutting off the potential amount of energy that flows through by adding resistance. So it only goes this amount of like current flows through the system. What I still am not 100% sure of is like, whether that current only changes at the point of the resistance, or whether the entire circuit changes current. Or does the current not change? Like, if I have a circuit and we're going 5 volts to 0 volts, or 5 volts to ground. Let me see, what is that calculation again? To calculate how much current that would be? There's like a formula, right? Where's that formula? It's like the basic stuff that you need to learn at like high school. Everybody's learned this. Everybody in chat should know this. Here. So if I want to get the current, I need to do voltage divided by resistance. So if I do 5 volts divided by resistance, well, I still don't know because I don't know how much the resistance would be. Yeah, exactly. You guys know. You guys know. Exactly. You guys are bosses. Would that mean, like, if I put a resistor in here and I measure before the resistance and after the resistance, do I see a change in current, or will the current just be the same regardless? Maybe we can try it, you know? Like, fuck it. Let's just try it out. Let's figure out how this multimeter works. So we have a breadboard. I wonder if I could zoom in without, like, making it too shit. Best way to learn it, right? Yeah. Zoom. This doesn't make it much better. This is good. This is better. All right. So how does a breadboard work? I thought this was actually a very ingenious way, but basically behind this piece of like rubber is just a bunch of conductive material that just connects every line here to as one row, I think. Or it's like this. No, it's like this. It's like these ones. So this is like one row, and all of these rows are not connected to each other. So this is all conductive material. It could be like any metals, really, that like can take some energy. God, the keyboard is so dirty. And so if you connect something to this, you're connecting power to that entire metal there, which is a super interesting way. So like, let's create a circuit, right? Let's create a circuit. First need to connect Arduino itself to energy, but we've got these two cables. One is plus, one is minus. So we need to connect some plus. Doesn't really matter where you do it, because for these ones, this whole row is connected. So for plus and minus, this whole row is connected. But for these individual ones, these are like connected vertically, like this. So this is one row, this is one row. So there's just metal, any metal behind this that's conductive. Okay, let's connect to Arduino. No, we should just connect it to ground first. I can't remember where to connect it to. Let me see in the book. Where's plus on this thing? Oh, it's here. 3 volts or 5 volts? What are we going for? 5 volts. Fuck it. Okay, so on the Arduino, there's like pins here at the top. And you can see it says 5 volts and ground. So there's 2 ground ports and one 5 volt and one 3 volt connector. So we're just gonna shove in the red wire into the 5 volts. Bada bing, bada boom. And then we shove it into the plus on the breadboard, so that this whole row, once it's powered, this whole like row is red, is like powered. But this, just a plus, having a plus does not do anything. Like, you can only have a circuit if you're letting energy flow from like high potential to low potential. So you need to connect it back to ground. So if we connect the minus on the other side, or like you could do it next to it, doesn't really matter because they don't really touch each other. We can connect it to ground on the Arduino, and now we could be writing circuits. But this already in itself is a completed circuit. So current will flow through this without any resistance, which means we could calculate how much this would be. So if we have 5 volts and we divide that by Let's see. Divide that by 0. Then we would have 0, right? Or cannot divide by 0. So what's wrong here? Why is this circuit not okay? Because if there's no resistance, there's just current of 5 volt flowing, right? Or is the resistance 1? In this case, I don't know. Does anybody know? If I have 0 resistance, will there be current flowing through here? Or did I just create like something that is like wrong? This should still work, right? Like there should still be current flowing through this circuit, even though like it's a short circuit. Oh. So why? That's interesting. Why would this be a short circuit? Because there's no resistance? Because you can connect it directly back to the source. And that's always wrong. Nope. I thought a short circuit was like something like that's bad. Oh. Okay, but then the formula doesn't hold up, right? Or is this just for Ohm's law? But how much current, if there's 0 resistance, how much current is there for 5 volts? New dis, who phone? Sup, cat? There should be some load resistor motor between the two. So you cannot have a circuit without having any load. Okay, we can put some load in though. Doesn't really matter. No problem, no problem. Okay, let's put some load in. So we need a resistor of... how much? I can't remember how to read the resistance color codes. Bad for the circuit. Usually will result in damage. Yeah, exactly. When I hear a short circuit, it's like, it sounds like you're just gonna damage parts. It's like you just short circuit your, yeah. Most of the parts are damaged. Do you think the Arduino can handle it? But yeah, let's build a circuit though. Let's make sure we don't fuck it up. So 220 ohm resistance. And then there is some diagram in here that shows the color codes for these. I just don't know where it is. Let me see if it is somewhere. How's your weekend though, cat? How do you want to be called though? Let me find resistance in the index and just say Ohm's law. Yeah, cool. Okay, let me find what I'm looking for here. It must be somewhere here. Alright, let's just find the right color. It's one that starts with... Probably have some loose ones here because you use these a lot for these LEDs. Look at all of this stuff. Look at it. Oh god, it won't stay in place anymore. It's sliding down. It was doing so well. Okay, we're chilling. Cannot see the breadboard anymore though. Do I have some spare resistors here? Okay, we'll just check which one it is. The power supplies I use can be shortened to allow for current limiting. Don't know what that means. I need to find this fucking page, man. Where is the page? Fuck me, I'm just too lazy to read it all. Because I've done this before. I just can't find the page that contains like the color codes for these resistors. Oh, here it is. Alright. Oh. What a mess. Alright. This is not good enough to read. So we have carpet. Otherwise I can't read it. These cameras, man. Alright. So we have a bunch of values, and then the amount of times 10 to the power of 10. And then with and then the amount of percentage plus or minus. Because it's not exactly the amount of ohms. As you can see at the top, the big example, it shows 1, 0 to the power of 3, 10 to the power of 3. And then plus minus 5%. So like the tolerance is 5%. So gold and silver. Silver is 10%. Why is silver better than gold? Or is this bad? Is it better to have a tolerance of 1, like plus minus 1%, because then you know what you're up against? Silver is worse? Yeah, that's what I thought, right? Because it could be also like less. Like the 1% one is the best. Cool. Alright, let's find the one that we're looking for. So we need a 220, which means that we need digit 1 to be red, right? Is that correct? Yeah, red, and then brown for, or not. I don't know how to read it. Be between 90 ohm or 110 ohm. Yeah, exactly. Yeah. Yeah, exactly. So there could also be a third digit. But we're building 220, right? So why is it purple on the image? Why is it purple? Or am I just looking at this wrong? In my book, it should be 220, and then to the power of 2? 10 to the power of? No, 1. So it should be brown. Oh, maybe it is brown. Maybe I'm just colorblind because of the light. Okay, then it's brown, so it should be 1. Because then it's like 220, right? Ohms, yeah. That's what it says. 220 ohms. And then the tolerance is like whatever. I think we only have gold ones, so. Okay, let's take a look what we have. Red, brown, right? We also have blue ones. I think we've used blue ones in the past, actually, for this. Where do all these hairs come from? What do the blue ones say? Oh, there's more specific. So they have 3 digits. Can always break out the multimeter and measure if unsure. Oh, hell yeah, dude, let's do it. So this one is... How do I know which way to read it? I think it's these blue ones. How do you know which way to read them? Because the... Not sure myself. Yeah, it's kind of weird. I think one side is thinner than the other. But what I see is like these ones are most used because they're bent. That's why I know. So you can see how bent they are. So I'm pretty sure I've used these ones before, which means that these are the 220 ones. But it's brown. You can barely see the color. Red, black. Red, black, which would be 220. Black. 0 multiplier, and then like red, like dark red, which is 1% tolerance. So these are the ones. But let's try it out, you know? Let's try it out. So let's put a resistor in place. Can I just put a resistor in place from plus to... Yeah, to the circuit, right? It doesn't really matter where. But we want to measure before and after. So if I take a cable first. So I have a resistor here. This is the color. If it were to focus. It doesn't focus. Okay, let's just put it somewhere. Measuring is king, right? That's what we're going to do. So I'm going to place it here, you're here. It doesn't really matter where you place it. Cool. As long as we put power to that. So let's take a cable, like a mini cable. Let's move that from plus to that row. I have a mini cable here. This might be too mini. Alright, beautiful. This one is nice. Okay, let's move it to that exact row onto the plus. God, this is so small, man. I'm trying to not push over the camera. Okay, let's put this one in first. Excellent. Okay. So we've got a cable. Hope it like actually focuses on the right thing. So we got a cable running from plus to 26. There's a resistor running from 26 to 18. And then we're just gonna put like a, I don't know, an LED or something. We tried burning an LED on stream, I remember. And so plus to minus, bada bing, bada boom, an LED. And then we take a cable and we move the minus to the ground. So the minus of the LED is now in, what is it, 17? So we're moving 17 back to ground. I love how I picked one that's just too big. I'm gonna push it in, you know. Fuck it. Beautiful. So we made a circuit here. 17 back to ground. And if we boot this up, this should just work. But I just want to know how I would measure something like this using the multimeter. Do I probably need to power it, right? Or not? Or can I just stick my multimeter in between? How does that work? Let's open up the multimeter. Throw you guys in here. So we've got the multimeter, which I've never used in my life. It's still in packaging. It's still, everything is new. I don't know what this is. What's this? Or just to plug it into the socket? To the wall? So we built a circuit here. And if I just power it on, it should just work. The LED should start lighting up, actually. So let's just do that first. Just for shits and giggles. How do I turn it on, though? Is it already on? Or is it because my computer is off? Hold up. Let's see. That is the wrong computer. Okay. I don't see a light turning on, though. Fuck. Do I need to turn it on? Is there an on button? Oh, that's not a button. What did I just do? Oh, that's just the light. Whether it's on or off. Why does it not work? Alright, I can plug it directly into the wall. Polarization of the LED. What does that even mean? Alright, let me open up my MacBook so it boots up. I don't know why it turned itself off, but it is what it is, you know? It is what it is. Let's see. Oh, I hate that it doesn't work. Sometimes it just does that. Oh my god. Why does this capture card never work? Hold up, let me open my screen. Maybe that's why. Okay, so there should be power though, but I don't see any power. But it's supposed to show an LED, no? Yeah, maybe it's not powered correctly. Fuck me, I put it in the wrong port. God damn it. Alright, it's working. Put it in the wrong port. It's fine. I just couldn't see where it was on my Mac. So I think I put it in not an USB port. I don't know what I put it into, but you know, it's fine. Okay, we've got a circuit. So let me put it back. So as I showed you, okay, so we have the plus cable here going into the plus. The plus connects to row whatever the fuck it is, 26. Can it sharpen maybe? It doesn't like it because of the LED. Yo, Weck! Thank you so much for the raid. Okay. So we got 26. So the plus, or the positive current, positive, whatever the fuck it was, goes into row 26, and then 26 goes a resistor of 220 ohm, and if we do the math correctly, if we take 5 volts, let me open my calculator. Calculator, that's calendar, okay, phone. Calculator. If we do 5 volts divided by 220, was that the formula? It was, right? Volt divided by resistance, we have a current of 0.0227 amp going through here. Sup, Noxanimus? How's it going? Sup, Lisa? Welcome back. And then that goes back to complete the circuit by going from 17 back to ground, completing the circuit. Excellent. So now my question is, how do I use the multimeter? Because I've never used a multimeter in my life. So how the fuck does that work? So we have a multimeter here. It's a DT5808 multimeter. And what we want to measure is the amount of resistance before and after the resistor. So how does that work? So if somebody could explain to me, because it's not in the book, I think, how this works. The LED also has a voltage drop as you have the subtract that from the supply voltage. The LED also has a voltage drop. How? You mean because it's a diode that it's like it's a tiny bit of. But why would the voltage drop? You mean from the LED onwards? Because I assume that the black one on the minus. Yeah, but how do I connect this? Do you know? Put the. These are fused. This is V. Oh, okay. Let me just get the manual. Need the power of the circuit first. Okay, let's do that. Done. Select the N symbol. Yeah, the ohm symbol. Yeah, but there's a couple of like. There's a couple ones in the ohm thingy. How do you type an ohm? I know what ohm is, so you can say just ohm. I even have temperature sensor on here. What the fuck? Does this need like batteries? Am I supposed to put batteries in this, or does this just work? Because I didn't put batteries in it. The LED has voltage across it, same as the resistor. Those two voltage always add together to the same value as the supply voltage. I think I want to measure voltage. Well, I just want to see. I want to see. Like, let me show you. Let me show you, chat. Batteries are needed? Thought so. I have batteries in the house, so. So this is what I explained before of my knowledge of like resistors. It's like you have 5 voltage going through this road, right? So you have like a road here. And so like there's a 5 voltage going through the circuit, and it goes from 5 volt to 0 volt because ground is 0 volt, right? So like the source is 5 volts. Yo, Aaron, thank you so much for the follow. If I put a resistor here of 220, right? 220 ohms. Does it like already resist? Like the current that is before the resistor, is this also lower than here? So what I don't want to measure resistance. I want to measure current, I suppose. Current is how many lanes you have. Yeah, exactly. But I put a resistor somewhere in the circuit. Does that stop this from not having these lanes altogether? Like, does this just not exist when you place a resistor down? Or does it like the first part of the circuit before the resistor could have higher current than the lower part? Or is that just not a concept? Does this not exist? Let me see how do I put the batteries in? Bum, 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 bum. 9-volt battery. In a series circuit, you have the same lanes just the speed is different. I'm getting hungry, guys. It's 7. Need to start cooking my shit. If the sign appears... Wait, let me see. If I turn this on... Oh, it just works. It has batteries already. It's on. Doesn't do anything. Okay, it doesn't need batteries. We're good. Okay. What should I measure? Let's just measure one thing at a time. So what should I measure, chat? What should we measure first? I've never used this thing, so... Just tell me something you know. Tell me something that I should check for. Voltage? Voltage would be easiest? Alright, let's check voltage. Okay, so I've got 2 V's on here. I've got voltage, white and yellow. Can it sharpen? Thank you. See, it has like 20, 200, 600, 600, 200, 200, 20. 20 volts is a lot though, right? Neat white. What's the difference? AC versus DC? Oh, okay. So this the symbol, the white one, is a DC, and then the yellow is the scribbly line is the AC. Oh, cool. Okay, it's good to know. Good to know. Nice. Thanks, guys. Okay. Don't want to measure 200 volts using 20 volts. Scaling. Yeah, but if I put 20 volts into the system, isn't that like just gonna change the formula, right? Because then there's more current flowing. So wouldn't I need more resistance then too? To make sure that my LED doesn't die? Just accuracy? Okay. So there's the white one above it, the 2000 M. Is that part of ohms? It is, right? No. Yes, no. What's that first 2000 M's? If you have a voltage of 1 volt and measure it in 200 volt range, you don't have enough resolution. Is it microvolts? You don't put current into the system with the multimeter, by the way. The numbers just indicate ranges.
I still have some light and cables here if you are interested.
Yo, thanks, Joshua. Thank you so much for the 38 centuries in a row. Free subscribing. Millivolt. 1,000 of a volt. You won't be able to damage this multimeter. Wait, but... You guys said... I thought you guys were saying that we're going to be powering the circuit with the multimeter. Or are we just measuring? Like, if we're putting 5 volts into the system and I select 20 volts, then it's like between 2000 microvolts, millivolts, and 20 volts, right? Let's put on 20 volts. All right, let's just fucking do it. Just measuring voltage. Sure. And then where do we put what? Does it matter? We need the dark. This one is always ground, I suppose. So we got that going for us. Black is always black. That makes sense. And then we have 10 amp max. We have... Oh, this is temperature. And then this is volt ohm hertz. So I suppose we need volt ohm hertz. Right? Because we're measuring volt ohm hertz. The bomb has been defused. Right? The black one is always black to ground, and then the volt, ohm, or hertz meter. The other ones are like amp, which is like reading the current, and then the other one is reading the temps. Nice. Okay, what do we do now? This is exciting. So we got this too. Do we need to power the circuit first, or do we need to turn on the multimeter? What's the steps? Oh, it says here the range here. So voltage range, 2 volts is 1 millivolt to 2 volt. Do I have 2 volt? I don't see 2 volt. 20 volt is 10 millivolt to 20 volt. Oh, this is the manual for a lot of other things. Circuit needs to be powered. Okay, let's power this baby up. Light is shining bright. 2 volt is a 2000 millivolt. Oh yeah, that makes sense. But we're measuring 5 volts here, so we need the 20 volt one. Cool. Okay, what's next? Now we just put minus the ground to ground, I suppose, or do we start with 1 first? Does it matter which one I do first? What's the recommendation here? Your chat is just telling me how to run this business. God damn. Okay, so we put minus to minus. I cannot stick it into it though. Does that matter? Do I just put it on the minus of the LED? Does it matter? Take another jumper and stick it in. Take another jumper. What does that mean? What does that mean? Jumper as in a cable. Metal has to be touching. Yeah, that makes sense. So you just want me to put a random cable up. Ground side of the LED. Yeah, exactly. That's what I was thinking, right? So just needs to complete a circuit. And then if I just hit the resistor part plus, or like any resistor part, then I'm gonna measure shit, right? So let's turn it on. So it's zero volt, which makes sense, right? So if I do, let's just do it closer. Bring chat a bit closer. Hold. Please sharpen. Little bitch. Stop sharpening nothing. Focus. Little bitch. Come on, you can focus. What do you mean? It's right in front. There you go. Excellent. Okay, here we go. Ground first. And then we should be getting like 5 volts. 4.7. Hold up. Can I show you guys this too? That's about right. God, these cables are terrible. I need multiple cameras. never exact. Yeah, it makes sense. So it says 0, 0. You guys can't see it because my hands are in front of it. Boys. It's moving. $4.72. A USB port is not an amazing power supply, I suppose, yeah. Look at that. We measured something. Okay, that's cool. That's cool. But this is what we already knew. You know, like, there's 5 volts going into the system. But what I'm interested in is if I measure the cable before the resistor, or the cable, the blue cable. Like if I take the LED ate some. I'll give you credit. Trying to learn electronics and test equipment on your own is going to be a challenge, but you're doing okay. I have a book here. This is the Arduino starter kit. It's helping me a lot. I'm reading a lot too, but like the testing kit, I don't know why it doesn't have a chapter about like the multimeter, but disregard that. Don't need to test that. So this is the amount of... Wait, so... Why did the voltage change when I hit the LED one? Is it not plugged in correctly? Is it not conducted? This is minus, plus. So why is it different when I check the plus and the minus part of the LED? So the supply 5 volt is dropped by each component in the circuit until there's nothing left to drop. Is that really how that works? Oh, that makes so much sense. That makes so much sense. Because I was looking into diodes, right? And they flow from like the positive to the negative. And then, right, it's trying to fill up like the holes, or it's trying to power up the part. So the material, the like conductive material here, or the diode in here, is like... Right. So this is like the YouTube video that I checked out. Hold on, let me show you guys. It was actually, it was mind-blowing to me, because I needed to use diodes for, like, I soldered that onto the ECU together with like a guy that was showing it to me. I also...
So here's a picture of a diode. These are some different transistors, and this is actually an i7 processor that has over 1 billion transistors.
I don't know if this is like, if I watched this video or whether... This is on semiconductors though. No, this is not the one.
So there's a little bit of a...
How do diodes work? Let's Google that. Right, let me check my history. diodes. Because the LED is just a diode that is emitting light, you know? Diode. Oh, how does an LED work? Is this a video I watched?
Energy released from normal energy to cross the junction and recombine with the holes in the P region. Initially, free electrons from the N region are.
I don't know if this is the one. I don't think this is.
Similar to.
This is not as clear as the other one.
At circuit, if you try the semiconductor region is at the top, then there's the area of the junction visible, and that's it. The valence band for normal silicon is in the form that allows free electrons to cross the junction. As free electrons cross the junction and recombine with holes, electrons release energy in the form of light.
Basically quantum physics. Oh yeah, that makes it a lot easier. Dude, where's the right video though? Why can I not find it in my history?
By number band. Example of a semiconductor. With this material, there's one, two move.
Or maybe it was the other one.
So here's a picture of a diode.
Maybe it was
with
this
things in
one.
it. Could enter this pure electric. Might actually have an electric current again because of the carrier, whether the charges that are this these that because it's depleted of charge carrier. You know, but in reality, actually, if this battery is really of any decent size, there's going to be enough electrons going in that actually they are going to start to get closer and closer to this depletion, you know, or to the
PN
to the
junctions
boundary, the
gaps.
PN junction. And at this
Yeah, so this one has like, simply put, right? So this is the positive and this is the negative, right? And this is like, the positive has holes.
same time, there's going to be a region will actually
where
just
these
collapse
things kind of
altogether,
just want to
and you'll
jump
start to
into,
get charges that can flow all the way
right?
through because you won't have the depletion region in the middle where.
And so like the closer this material gets, the easier, or like, yeah, the more frequent it happens that this like jumps over, right?
No charge carrier.
Am I like, is this a way too simplified video, or
terminal over here?
or
what's
maybe
gonna
I just
happen is some
understood
of
it way
these,
too simply?
these
But
electrons here are going to be attracted towards the positive.
you need
terminal
high
of the
enough
battery.
voltage
So
for the
some of
electrons to jump across. Oh, okay.
electrons will start.
I
To,
see.
Will start to leave.
And so when you flip them around, this gap becomes bigger. And so this will
they
result
can
into
go
like
in one direction.
pretty much negative or like infinite resistance, right? Because it's like the current cannot flow through because there's no the jump is too big, basically. You need even bigger voltage. Yeah, right.
That are flowing.
And then the diode itself, this gap, like if you add more voltage, they get closer together again, right? In theory, like if you just look
on
at
the
it
negative
visually.
side. And it's a little bit, but it actually it's positive to
And
negative.
then that explains why some diodes have a higher capability of handling higher voltages, right? Because they are made to still, with a higher voltage, still be able to have like high resistance in one way. And in the other way, low resistance, like near negative, like near zero resistance, right? That's what I understood from it. Like basically, we just added a diode in one of our parts just to make sure that if there's a switch or that there is actual voltage going to that system, that it would not actually complete a circuit. So there would never be power flowing through it like in the other direction. I don't know if that makes any sense. But anyways, it's just to protect a part from high voltage if it comes from a different part. Okay, so so what you're saying is we're starting off at 5 volts. All of these parts have these like plus and minus parts depending on the material used, the junction for them to have electrons generated by just flipping these, whatever the fuck the material is called? P and B?
Find it really
Or is it always P and B? Protons and whatever the other thing was? Created like electrons, right? So like in this material, in the LED, there is some of the energy of the 5 volts is used to do this jumping. For normal diodes, it's silicon. Okay. And it is, yeah, so it's silicon and then it has like some holes filled. That's what, at least what the video explained. It's like,
because a lot extra added.
if
to
you have just
silicon
silicon,
is
then everything
phosphorus.
is in like simply
And
in
phosphorus
place.
has 5 electrons, and
And then they
so it has one
switch it up with just adding some
extra
P
electron,
and
it has 1 extra proton. Beyond
this voltage also defines the color. That's why different colored LEDs have different voltages. Oh. Okay. Interesting.
what silicon has. And so if we replace this atom here with a phosphorus atom, it would still bond to the 4 adjacent
Dude, this was always
silicon
something that
atoms
I
just like this,
just,
but it would have this extra.
I had like no
extra
interest
electron
into
in there as
whatsoever,
well.
and look at me
And
now.
maybe if we replace this with a phosphorus, it would
It's
have
the most fucking
an extra
interesting shit that's on my
electron there.
mind.
And if this were a phosphorus, it would have an extra electron there. And so we have these extra electrons that
Enjoy your
we're
coffee, Doug.
introducing into this silicon crystal. And so we've
Yeah,
got the same
I'm
basic
very
structure,
happy
but
that
now
you
we
guys
have
are
these
here. Thanks a
electrons
lot.
that can actually start to
Relly,
wander around a little bit. They're
Cheese,
not going to go too far from the
Doku,
phosphorus, but as long as we've
Doug.
got enough phosphorus in here, these electrons might wander around. So this electron here might actually kind of
different
wander over here, for
semiconductors,
example,
like
and,
gallium to get the colors.
this
Gallium.
electron here might. Oops.
So basically, if you have just a normal, if you just have normal silicon, all silicon, is this atoms? Or like, am I just, wait.
Not it. And what's going atom?
Yeah,
It's
so
going to have 4
a silicon
electrons
atom,
in its
if you have a
outermost,
bunch
like
of silicon
its
atoms
valence
together,
shell. And so when it bonds to another silicon atom, you're going to have this.
There's
this,
no
sort of covalent bond
like-
between the two. And so in a whole lattice or like a crystal of silicon,
it's like it's a
all of these
stable
electrons are gonna
material,
be
right?
tied up in these
Basically an
covalent bonds.
insulator.
And so none of the electrons are going to be free.
Yeah, so this is not conductive. This is not conductive material as of now, right? Because it's too stable.
to move around, at least not at any kind of normal temperature.
I
that we're
understanding that
defining this
correctly?
at. And since in order to
Yes,
conduct
okay, thank
electricity,
God.
we need to have electrons that,
Oh,
that can move around.
Damn, we're learning.
Perfectly pure
We're
silicon
learning.
like this actually doesn't conduct electricity. And so actually the silicon that we use to make diodes, transistors,
So why is it called semiconductors then?
microprocessors, and all that sort of stuff.
Is it because it's made off of a not conductive material combined with conductive material?
Actually has some impurities introduced, which is something we call doping. And these impurities allow it to
Make it conductive by heating it up.
conduct electricity in a particular way.
Oh.
And this doped silicon is
But
what we
that
call
does that depend on, or by putting impurities in it?
semiconductor material, since it's not
Right.
really a regular conductor like copper wire,
Oh.
but it's also not a complete insulator like something like glass.
Wait,
So
so
one of the impurities that's commonly added
wait, so would that be how a temperature sensor works? Like by changing the heat, or would that not make any difference? Like the material used in a temperature sensor makes it conductive or non-conductive? No, because a temperature sensor would always be measuring, right? Or would it be more conductive and less conductive depending on the temperature?
to silicon is,
there are better
is
materials? Okay.
phosphorus. And phosphorus has 5 electrons, so it has 1 extra electron and it has 1 extra proton. beyond what silicon has.
So,
And so if we
what
replace
he's explaining
this,
here
this
is just like, I don't know how you would do this on an atom level, or whether there's like materials right now in the world that are just this atom structure. I don't
atom
know.
here with a
Like,
phosphorus
I don't have enough knowledge, but like,
atom, would still
by
bond
making
to
it
the four
unstable,
adjacent
you've made it
the silicon atoms just like this, but it would have this
conductive.
extra electron in there as well.
And is it
And maybe if
semiconductive
we replace
because
this with
of
a phosphorus, it would have
the fact
an
that it's
extra
like made of?
electron there, and if this were a phosphorus, it would have
Yeah, you made
an
it
extra
conductive
electron
because
there.
of
And so we have
making
these
it
extra
unstable
electrons that we're
that are jumping
introducing into
around,
the
right?
silicon crystal.
Jesus
So we've got the
Christ.
same basic structure, but now we have these
I'm not sure if I'm
electrons
just
that,
like
that can actually
mind
start to
pooping
wander
myself.
around
I'm
a
just
little
getting
bit.
more
They're not
confused,
gonna
or
go too
whether I
far from a
actually
phosphorus,
understand.
But as long as we've got enough phosphorus in here, these electrons might wander around.
He's
So
added
this-
free
this
electrons. Yeah,
electron
exactly.
Here might actually kind of wander over here, for example, and this electron.
And
here
because-
might, oops.
And
this
because
electron
you've
here
freed
might wander over
electrons,
here, and so these electrons can move.
This is
move
conductive.
around. And so because the electrons can move around, this thing is actually kind of a conductor. So if we hooked a battery up like this here, we'd be able to get current to flow, right? Because electrons that come out of the
Look at
negative
that.
terminal of the battery could enter this crystal structure and move around. And there's going to be free electrons here that can be pulled out of this crystal structure and attracted to the positive terminal of the battery over here. And so just by doping this silicon
what
crystal with
conducts
a
in
few
metals,
phosphorus
the
atoms,
free
we can get
electrons.
an electrical current to flow through it. We can turn this into a conductor. And so that's one kind of doping, but there's another kind of doping where we use boron. And boron
I really need to start
is
making some
basically
food.
the
I
same
wonder
as
if I should
silicon,
leave the stream on.
except that it has one
Or
fewer
whether I
electron
should,
and one fewer proton. And so if we were to
Or whether I
replace
should just
some of the things in this crystal
stop.
structure with boron, we replace this atom with boron.
Because I'm super interested. Like, this is such... It all makes so much more sense. I remember almost a year ago, probably, that we started this, and I never continued. We just got some shit to work, and that was, like, cool and all. But now I've read so much more.
We'd have
and I've
one fewer
kind of, like,
electron there.
read
And
the
if this were
actual
boron over
electrical
here,
diagrams
we might have one fewer electron there.
of some of
And
the
if this were
stuff that I
boron
work
down
with.
here, we might have one fewer electron there. And so that leaves these
Now
sort
it's
of-
starting to
these
make a
sort of
lot more
holes
sense.
here where these electrons that would normally be part of these covalent bonds are kind of missing. And now what might happen is that now that these holes are here is like other electrons might actually kind of jump out of their...
Okay, but then, now we're then back to where we were, which was here. So 5 volt goes into the system. 5 volts goes in through a resistor. The resistor doesn't change the voltage. The resistor changed the current that is allowed to flow through this circuit. The material inside of the material inside of this LED. Wait, does the resistor have materials in them that change the voltage, that take up voltage? No, right? Because then the formula doesn't hold up. Wait, let me take off the power. Let me move some of these cables up just a little bit. Just so I can touch them with my multimeter. Just enough that they still also touch the metal though. But we'll see that soon enough. If the LED doesn't like power up, then we know. Let's see if it still powers up. Okay. The resistor behaves to formula. Yeah, exactly. Resistor is an ohm resistor, so it functions according to the law of Ohm. Yeah. The diode is not. In simple terms, it has a constant voltage drop. Right. Yeah, that's what I thought, right? So the resistor doesn't change the voltage in this case. So if I test... Why is it 2.8? What? Hold on. Is it because it might not be properly touching the metal now to create a circuit? Wait, let's put this... Isn't that the diode drop? I thought we said that it doesn't change. If you want to understand the voltage occurs a diode, you have to look at the Shockley diode equation, but that's a bit advanced. .9 volt in the LED. So then every part of the circuit is distributed to make it 5 volt. So like if I just test the resistor, .7 1.9 put 2 plus 2.7. Yeah. Don't fully understand, but... Is this... So... Maybe I understand though. Maybe I do understand. So, this LED... current flows through the circuit. Depending on like the formula that you use, that's the amount of like from 5 volts to 0 volts with 220 resistance. You can calculate how many ampere like current flows through the system. Every part uses a certain amount of voltage, and then the rest is distributed to parts that don't. Is that how I need to see it? So like, if I added more volt and a higher resistor to make sure that the LED doesn't burn down, like a more powerful resistor, this LED would still take 1.9 volt. You're measuring the difference between the probes, the multimeter probes. If the black should be on ground, M is measuring the difference between the probes. If the black probe is not on ground, say it sits on 1 volt, you will be measuring the difference between the supply of 5 volts and the 1 equals 4 volts. Yo, you don't thank you so much for the 63 centuries in a row for subscribing. Thank you. Welcome back. That's why black needs to be on ground. If I do ground to ground, it should be 0, right? And then if I do start to ground, it should be like the max. Which is the same as if I measure here because it's the same. Yeah. And then if I, okay, right. So if I do this, this is still ground though, so this would still be the same. Oh. Right, but if I do this, this is the difference between this. I thought an LED was a diode. An LED is a diode, yeah. It's a light emitting diode. So the 1.9 volts you're measuring is what is left of the supply 5 volt after the resistor drops some of the voltage. Okay, so right. Okay, I think I understand. So, in theory, you could say this whole breadboard right here, as it is like set up right now with the cables, with the resistor, with the LED, that's a circuit. But also, this plus part of a resistor and to the negative part of the resistor is, in theory, a circuit that flows from a positive, like, what was it called? A positively, like a high, what is it called? Just to make sure that I use the terminology correctly. A high energy source, or like a high... Look, where was that page? That was such a nice page. Here. High potential energy to low potential energy. So the plus side of this resistor still flows energy from plus to the negative. So you could say like this is a circuit, right? But could you say that some of the So you could say the end point of this resistor is the high potential part of the next thing, which is what's happening, right? So like the end part of this diode, so if you simplify this circuit, you could say the negative part of the diode is the plus. So you could simplify the entire circuit by saying the end of the diode is the plus of the LED of this circuit, let's say. So that's like, you could leave all of this out, and then you could say the starting voltage would be whatever this is. 1.9. So after the diode, the starting voltage per se, let's say, is the same as removing the resistor, removing the cable, as if there will be 1.9 volt coming out of this Arduino right now, right? So I would not need this resistor if there would be 1.9 volts coming straight out of this Arduino into this breadboard, into this LED, back to ground. 0 volts. Really hope I got this. Really hope I understand it now. That simplifies electronics a lot. Because then, in theory, you could be building... Wouldn't the current spike then? Why? It's the same amount of volts. The same... We can do the math for this though, right? We can do the math for this. In theory. So I can do a calculator, and I say 1.9. This should return the same. So I don't know exactly what it was, but like around the same. 1.9 volts. If we want to measure the current divided by the resistance, but then there's no resistance. Right? So then it would be a short circuit. So you always need to resist somewhere. The problem is that an LED needs a current limiting device to not be destroyed. Do the resistor, do the math for it. Well, I would divide it by 0, right? So then it would short circuit. Because then the... Interesting. So in almost all situations, I say almost because there must be some way where circuiting is fine. There must be a place where this doesn't hold up. But maybe there's not. Maybe there's not. But you must then always have somewhere in the circuit you're starting. Then my theory doesn't hold up. Because what my theory was is that I can simplify the current circuit by saying our starting voltage is now 1.9 volts. So your starting voltage would always need to be higher because you always need the resistance in between. Tell you what, let's measure resistance, turn off the power of the circuit, and then put the probes at ground supply. Will be easier to do calculations. All right, turn off the power. Let's do it one at a time. Turn off the power. Done. Turn the power, then put the probes at the ground supply. But then do I need to change anything here to measure resistance? Remove the supply wire. Check. Ground would still be ground? Or also, that's also gone. Yeah, the resistance. So which one do I need? The lowest one? Or the medium one? Let's just do 2K. That should be fine. Because the lowest one is 200. So I would say probably 2K should be enough. Or not. Yeah, okay. Ground should still be there, or does this function as ground? Because it's just flowing from like a higher potential, which is also the difference, right? I googled how does a car with rubber tires have a battery but no ground? Because, you know, it's not on the ground. But then, you know, once you understand that electricity flows from a higher potential to a lower potential, that changes a lot. Because that's what you can create in a battery, right? You can create a higher potential, lower potential. To make it flow. That's what a battery does. A battery, you can have a floating electronic system with the battery floating on without touching ground, or like have it on rubber things that it's non-conductive, and it could still work because the ground is just the car of a ground is also connected to chassis. Yeah, but that doesn't. Does that make it lower potential? I think that's just for convenience. So you can connect ground via the chassis. But I think the ground of the car still then connects to the minus part of the battery. That's just for convenience. So like if I have electronics in the back and I cannot get to the minus part of the battery, I can just connect it to the chassis and then go from there. Right? Or maybe I'm wrong there, but you can put a lamp to a battery and throw it in the air and it will still lit until it smashes the ground. Exactly. Okay, that's good. Because it's just artificially, like the battery is artificially like created like attraction, like I don't know how that works. I've googled how a battery works, but it's fucking complicated. First measure the resistor, leads on each side. Do I remove the, does this matter? The ground one? No, right? Okay, what is 1? Is it 1 ohm? Do we always have 1 ohm? Go ahead and remove. Okay, it's really... If you're saying it doesn't really matter, then it's all good as well, but... Okay, start. First, measure the resistor. Leads on each side. $225. 227, 226, 227, 228. Maybe it's because I'm just holding it wrong, but 227. So these are 220 resistors with a 1%. I think that's what it said. Too high to measure. The resistance is infinite. So if I did ground to ground, that matter? I don't know what I'm measuring. But there's no ground here, right? What is ground here? If I plugged in the ground, would that mean, and I measure the same? So if I just measure the same side, right? That's like something you could do. Fuck, how do I do that? Why is it not 0? How is it possible that the resistance on how is there still a resistance difference between one part of the conductive material and the other? It's close to 0. Okay. Is it the meter just like not being super 100% accurate? Or would you say it's like... Would you say it's like... You put the probes together. It's all over the place. Why is that actually? Meter and your cables. Oh, true. Right, I'm pushing hard. Now it makes more sense. Okay, also near. Maybe this is the bad multimeter. That would be your offset. Or would it be like if I switch this to 200? Oh, this one. 200 ohms. This is like low as can be. What the fuck is this value? Just the offset of the instrument. Okay, fair. Cool. Okay. What's up, Yuka? Good to see you. You mean like this? Touch in parallel. Move service that connects. Combination of contact resistance, cable, and not so good build instruments. I mean, this is not a very expensive multimeter, so I mean, makes sense. I don't know how much this one cost. It wasn't like an expensive one, so I'm fine with like having some weird offset there. Let me see how much it costs. this together? Yeah, yeah. We're measuring ohm. Wait, where did I actually order this? Oh, here. 24 euros. Is 24 euros okay? Is that a fair price? It's not something you normally need. Yeah, yeah. Cool, okay. So, what are we measuring? The difference between plus and minus. So it's 222, something like that. That should be good. That makes sense. 1% off, like, offset for these resistors, so this makes sense. You mostly need to know whether it conducts or not. Okay. Why were we doing this again? I can't remember what we were doing. Could now calculate the current through the resistor. Don't remember the exact values. Sure. Oh, you mean for a part of this? So I can calculate like how much, but I thought hot current was just flowing through the entire system. There's no difference in current in each part of the system. It's like from 5 volt to 0 volt, that's the amount of current you're gonna get. Or are you saying like if you minimize the circuit and you say like the ends of the resistor here is the starting point of from the LED onto ground. Current is going through all the devices in the circuit because it is in series. Yeah. So if I have a parallel circuit, does it halve the current for both of these? Or not? Because the input doesn't change, right? Like there's only 5 volts going in. Parallel to what? If you just have another set of like LEDs, I suppose. So like there's plus coming in here. If I just had another resistor set there, and then another LED there, and then both the grounds. Not only the current in the supply will increase.
Everyone, get in here!
Yo, Fulgy, thanks so much for follow. Welcome, welcome. And internet gone. If you get parallel, your voltage stays the same and your current changes. Yeah, that's what I thought. But, okay, so then my question continues. From... the current in these parallel lanes will then change, right? And then let's say both of them connect back to this cable. If I check the current of this cable, it would be just the 5 volt to... oh no, there would be more resistance. I don't know. It's now getting even more complicated. I thought I understood it. Does this mean 0 resistance, or does this mean 1 resistance? Or is it because I'm measuring too high? If I'm measuring the LED. It's way too complicated right now. No, he's I'm learning a lot. I really appreciate it. Everybody. One out of range. So the resistance is below this, maybe. No. How can this be high resistance? Across all diodes, the resistance is infinite one way and real the other way. Yeah, but that's what I thought, right? But I did plus minus. So I thought or is the resistance the other way? Put on diode mode? Is there a diode mode? Is it the other way? I can test it the other way. But it's also nothing. What's diode mode? What is diode mode? Do I know if there's a diode mode? Oh wait, this is the icon for diode, no? The white one. In the top left. That's next to this 200 one. That's the icon for a diode, I remember that. What is the other icon above it though? What is the fucking wireless icon? Is it gonna beep? The fuck? Continuity tester. Okay, so I can set this to diode mode. And then I can test an LED because it's a diode. Because LED stands for literally diode. Oh. So now it's light emitting. Very low though. And then it should be nothing if I do it the other way. But what does this mean though? What does this do? Why is it, how, like, what? Like, why is there current flowing through this? Is the system transferring current through this? LED has polarity. Oh, I've seen this before in when I started the stream. Can't remember who said it though. It is supplying current, but how does it know how much? Is it just gonna try? I'm just gonna try something. I'm just gonna run through some. I don't know what polarity means. You have the black lead to the cathode. The lead is working. Yeah, I know. Because it's one way. It's one way. Maybe to 1 milliamp of current. Does it say on the device? Isn't that a bit random? What do you guys think? Isn't that just gonna be like fucking up some of the stuff? Especially if you're working with like some stuff, you know, like that are just measuring for a specific amount, like specific current to flow through, or is that never the case? It's low enough not to mess with things. So your multimeter has a 9-volt battery. I didn't know that. But I think it says that, yeah. I suppose it does. Nine-volt battery, yep. Battery type 9 volt. Is 9 volt a normal battery? Does it bleep if you short them? How do you short them? If you do it the other way, is that shorting? No, right? That's just... How would I short them? Short the leads. Oh. Yes, it does. It did give a beep. Very short one, though. What does that do? How does it... Did I just do something? So I just short circuit, but how does this device... Is there a limited amount of fuses it has or something? Did I just burn through a fuse? Low enough it will beep, but what does it do? How does it not destroy? Or is this one of those cases where short circuiting is like fine? You can do it all day long. Dude, I'm learning so much. This is so interesting. I really appreciate it, guys. And girls, and whoever is in here. Really appreciate it. Measuring voltage drop on the leads while it is supplying a current to the device under test. Measuring a voltage drop. Okay, so there's 9 volts flowing here, right? 9 volts going through. 9 volts, and I'm telling the device, or I'm like creating a circuit by, without any load, by saying 9 volts go to ground into this device. So 9 volt to 0 volt. But normally if I were to do this, it would be 9 volt to... But it would still be 9 volt to 0 volt. Because that's the circuit, no? Or is it because the voltage of this thing this takes some or not? This uses some of the voltage, right? So if I were to start from here to here, well, it should probably not be in this mode. Or does it? Wait, can it be in this mode? It can, right? If I say plus here, oh, my multimeter is stopped. The fuck? Oh, it's because it's probably in this mode, and it's like, oh, if you don't do anything, I will remove the electricity from it, right? Because you don't want to, like... If I put this into myself, there's 9 volt, right? Or not? Okay, but if I do... You probably don't feel it? Oh, okay. So if I do to the plus of this when I turned it on, right? Just to know. So if I do plus and then to ground here. And this thing has 9 volts. That would be a short circuit as well, though, right? Because there's no resistance. You can try it on your tongue. That was a bit scary, but, you know. It's like licking a battery, I suppose. People do that too, right? Thing of the multimeter as a current source, not a voltage source, that's maybe a more complicated topic. Okay. I'll you know, I'll take it. I'll take it. Okay, fair. I'll just do that for later. All right, I really need to eat though. It's 8:30. And I'm hungry. But we've learned a lot today. The only thing we haven't touched is measuring amps. So should we do that as the last one? There's a small internal resistance and fuse inside. Yeah, but a fuse burns, right? Or not? There's a fuse is like a wire, right? That like, because of the heat, it would then burn and then your fuse is gone. So you need to replace the fuse. I don't suppose you need to replace a fuse every time you do that. Where are you living that it's 8? I'm living in the Netherlands. 8:30 p.m. Anyways. How do we use the amp one? So that would mean measuring current, right? So that would mean powering up the system. And then I can say, depending on how much, right? Because then you need to switch this piece off and you say like 10 amp max. If it goes over 10 amp, you're just gonna burn a fuse. When you take a bip, what is a bip? In diode mode. That means that the circuit... Oh, a beep. In diode mode, that means that the circuit is not interrupted. They normally have fuse. It should say on it fused. Yeah, it has fused. So that makes sense, right? Because like if you're going over, like this is current, so like this is actual electricity flowing through the device to measure, which means like if you're just fucking throwing like, you stick these into your wall socket, I don't know how much like voltage is from your wall socket, but I suppose it's quite a lot. And then you would also need to add the yellow one because it's like it's AC, right? You can easily short things. Current mode. Okay. But why is that? Because if your system is already running at that amount of volts, is it because if you put something in between, it uses the current? Is that it? With the lead black and touch the red lead, you'll have a bip in diode mode. Yeah, that's what we just had. You guys want to hear it? Wait, why doesn't it work anymore? Oh. Okay, we're chilling. Beep. It's like a really low resistor. So, okay. Okay. So for this circuit, it doesn't really matter, right? Like, if you've got the circuit working, low value. Of course. Of course. Of course. Okay. So in theory, if I plug this in, I put plus back. These are cheap materials, right? So we can just fucking short circuit this. No problemo. Plus to minus. We plug this in, and then we touch minus here to plus there. We would exactly get the value that is 5 volts. No, that would be a short circuit. Right? Because there's no resistance between what I'm measuring. Yeah. Okay. So if I did it after the resistor, then it would be fine. How far do you live from Schiphol? I live 20 minutes from Schiphol by car. Maybe even shorter, 10 minutes. Current would be 5 volt divided by multimeter resistor. Huh? What's how? Because it's after the resistor, no? So like the circuit that I'm making is 5 volts. So this, what was it? You have the anode and the other one. What's the minus? Just wanted to use the terms again. Someone is asking Boyd out for a date. Sup, Bowley? Holy shit, long time to see. How's life? Jesus. How's life, girl? Do you have a resistor in serial with the LED? Yes. So if I... So like, right now... Okay, wait, I can show you. Oh god. Why is this thing never doing anything? Come on, you can do it. You can try it out. You should not be able to break things. Yeah. So you can see that the... Hello? Can you sharpen? This is the only thing in the view. Like, how do you not sharpen? What? Bro. So if I touch the minus part of the resistor, then it would exactly be the formula, right? 5 volts divided by 220 ohm. That would be the current. And the same would be if I measure from start 5 volts to ground or not. No, not to ground. To like the... What the fuck was that other word? Why is it not fucking... Focus. Focus! You little shit. Focus, you damn shit. Why is it still focusing on me? Focus on this, bro. This camera's shit. This camera's actually shit. Oh. Just kidding. The instrument is measuring the current that is flowing through it. Yeah, so but the current is what we're measuring, right? So 5 volt divided by 220 ohms would be something. So to measure current, you have to break the circuit. Let me think. Why? How does that make sense to me? It's like you want to measure the water flow in a pipe. Uh-huh. Current is like how many liters per minute? Yeah. Right. For that, you have to break the pipe and put the metering device in between it. I'm trying to think. I'm trying to think. So this whole circuit is one pipe. Or is one device one pipe? I'm trying to think. If I have... Does it make sense? No, not yet. I'm trying to figure out if I can make it make sense. So if I... It's not on, by the way. It's not on. So I'm just using it as the point. And I can see if I can make this focus again. Well, it's just like pressure. You can just drill a hole and put a pressure gauge to it, like probe the tip that does not work for the flow. I'm trying to think, but how does it not work in this case then? Okay, let's say if we have this example here, right? This weirdly drawn highway. We got 5 volts. This is the current. This is in this case how many cars, right? The amount of cars per something. And then the resistance is like fucking cutting the you know, the road, making the road like shorter, or like not shorter, but like the lanes of the road, cutting the lanes of the road. So measuring resistance, what would that? Okay, but we're measuring current here. So like, wouldn't it just be, maybe I'm just wrong, right? So, but this is like my question since the beginning. This and this, if I'm just like putting a probe at the 5 volt start, Car's not a really good example. Fuck. True, because it's like you can physically count them, but like with water, it's like flow. If you have a pipe, like if I have a resistor, does this make the overall pipe smaller? Or does it only cut after a certain point? Because if I'm measuring from this starting point to, well, even after the resistor, and I put my other probe there, it would then complete the circuit, right? Or would I just get like a weird, would I just get a non-important value? Resistor is a smaller pipe. Yeah, exactly. So here in the circuit, right? I have this circuit. I have the circuit that we have right here. So we have like, how do you draw that again? It's like this, right? A battery. And our plus is going to a resistor. I don't know how you draw a resistor. It's fucking 220 ohms. I don't know what the sign is for a resistor. Into the LED. I don't know how you. I can't remember how you draw that. An LED is a diode. So is it like this, or is it the other way around? Does it not matter? This is the circuit that we have, right? It's the right way around. Cool. And so if you look at this as a physical like thing, right? If I put a probe here, I would have 5 volts like starting, but there's no circuit. If I then put another probe here, would I then have... Oh, but then it's a short circuit? Because it's like going directly from without going through the resistor? Oh no, wait, we're putting it in the LED. So if I put it here, or would that then also short circuit because you're circumventing the resistor?
Everyone, get in here!
Yo, Mino Tim, thank you so much for the follow. So this would also be short circuiting because you're like, electricity finds the easiest way, right? The least amount of resistance to get from point A to point B, and point A is like the plus, and it goes to the attracted point on the negative. Also, it's kind of weird. Some people say it like flows the other way. I don't know if that's true. It's whatever. Right. So when I put it in a diagram, it makes a lot of sense. Because like from the diagram, it physically shows that you've created an easier path for the electricity to flow, circumventing this part of the circuit altogether. Right. Okay. So then you would need to, from the negative pole, electrons come out of the negative pole. Okay. Okay. that even thinking about that just makes my head spin. But okay, but if I would want to test in this circuit, just to make the formula present, right? Just to make sure that our formula makes sense. Right? what kind of changes would we have to make to this circuit to make it work? Would we then have to battery, right? Start a probe. to a resistor, whatever the icon is for that. I think it's this, at least in my diagram. Then you're just using cut the wire and put the meter there. Right. Yeah, okay. Right. So you would become part of the circuit. You cannot just put it somewhere in between. You have the multimeter be part of the diagram. Yes. So in this case, it could be even this multimeter out to the resistor to the LED or diode, any diode for that matter. Right. Because if you loosely put it anywhere else, you're creating an extra way for the electrons to flow, causing a short circuit because you're probably circumventing some part that you shouldn't. Okay. Right. Okay. Wow, electrical diagrams. Would you look at that? We do be learning. Why you have the LED in between? Because that's what the current circuit had. So I'm just drawing what we currently have. Also, is there a different symbol for an LED or versus a diode, like a normal diode? I see like this. In my diagram. Has two small arrows. Shows that it's emitting. Okay. Yeah. That's what I'm seeing in the book as well. Oh, that fucking thing will never focus. It's just that I remember like what a battery looks like in the videos I've watched. Okay, cool. Thanks everyone. I'm gonna enjoy my food. Gonna cook and then I don't know what I'm gonna do. I'm not sure whether I'm gonna continue. I wonder if we should actually try to make this circuit work with the amp meter, because now I kind of understand. In theory, we could just lay a cable on the table. If I had like clippers, I would just put a clipper on the rubber part so I can just like put the two pieces. Never drawn a battery like that? This is what is shown in the video every time. I don't know if this like if this amount also matters, like this amount, whether this is like the amount of, if this is actually like an actual thingy. What I could also do though is remove a cable. Oh no, I need one cable sticking out. A cell, yeah, that's what I thought. Because I was looking at like the 12-volt batteries in a car, and then they have like, this is one cell, right? It's funny because if you read it, it actually makes sense. If you're thinking of it like this is a plus, it's not touching the minus because that would be like fucking electrons floating around. So these parts are not touching, but the minus part. Is the minus part like not touching the plus of the next one either? So it's like this, right? Like you have the pluses, and then, oh, fuck, how do I draw this? It's like you have a battery, and then the outside casing is like the minus part, right? So this. It's like the minus. I don't know if I can. Whatever. I'm not even gonna try. I'm not even gonna try. It's too. It is what it is. I actually thought, wait a minute. I was like, wait a minute. If the minus is the minus part touching the plus side of the next one. So that you have a, but that doesn't work like that, right? Because I thought it was like if you combine batteries, it's the same, right? It's like, can this work? If I have a battery like this, and I add another battery to the back of this one. Oh yeah, I actually, wait, there's a video about this. This is like, you're increasing the amount of volt. Right. I can't remember. Okay, there's two setups. There's like the parallel one, where you're putting them next to each other. Like this, because I know if they have not enough space. And then you have this one. I can't remember what the difference is between the two, but... Something must happen there. Otherwise it's like free flow. I don't know. I can't remember. Anyways, I'm gonna get some food because otherwise I'm gonna die. So, thank you guys so much for watching. What hydraulic suspension do you have again? It's in the beginning of, the system is called Hydractive 2. In the beginning of this stream, I explained it. If you want to watch the VOD back, I have like, in the beginning of it, it's just like, one is in parallel, one is in series. If you put them next to each other, you keep the same voltage. Yeah, exactly. But then they use less of each one, right? It's like they drain slower. You just have increased capacity. But like this one is like increase like output. You now have more voltage. So that's what a 12 volt is, right? In theory, it's like just a combination of smaller batteries. I'll just put it on YouTube, Hyuk. I'll put it on YouTube. It's fine. Anyways, thank you guys so much. See you guys later. Might do another stream where we actually work on the projects. that are in here. So for those of you that don't know, I have this Arduino starter kit. It is something you can just buy. You get like a lot of different stuff. You get like mini motors and everything that's basically on this thing is what you get. And it just explains to you what you have to do. And I just did a little like side stuff because I have a problem with my car that I'm trying to figure out. And I just love mechanical engineering now, and I also love electrical engineering now. So I'm just super interested. So I started like looking more shit. That's what we're doing. But I think we should just continue with the Arduino book and just see what stuff we can build. So thanks everyone, and I'll see you guys later. Bye.